Today we're going to discuss about the probability. Okay, now look, before going to the main topic, we have to learn few definition related to probability. First of them, what is the random experiment? Random experiment. Have you any idea about the random experiment? Anyone? Have you any idea what is the random experiment? I'm waiting for your answer. Do you know what is the random experiment? Okay, no problem. I'm telling you the definition. Look, an experiment is said to be a random experiment. An experiment is said to be a random experiment if three conditions are satisfied. First one is all the outcome are known in advance. Number two, we can't predict which outcome will surely come or surely occur. And third is the experiment can be repeat infinite number of time. If any experiment satisfies these three conditions, then we can say that the experiment is a random experiment. I'm giving you example. For example, if you have a coin and you toss the coin. Okay, so this is an experiment. Can you tell me what will be the outcome in case of tossing a coin? When you toss a coin, so what will be the possible outcome? No, yes, two possible outcome may occur. The face may show head or the face may show tail. So two possible outcome may occur in case of tossing a coin. That means before doing the experiment, we can predict that which outcome, we know which outcome will occur. It will be either head or tail. But can you just predict surely that the outcome will be head or the outcome will be tail? Can you predict it? When you toss a coin, can you say that the outcome will be definitely head or definitely tail? No. That means we can't predict which outcome will surely occur. And third case, the experiment can be repeated infinite number of time. We can toss a coin infinite number of time. So as tossing of a coin satisfied these three conditions, so we can say that tossing of a coin is a random experiment. Similarly, if I throw a die, okay, I think you know the die. So when we throw a die, we know that the result will be either 1 or 2 or 3 or 4, 5 or 6. The face so will be one of this number 1, 2, 3, 4, 5 and 6, isn't it? That means before doing the experiments, we know what will be the possible outcome. But can you surely tell me that which outcome, that means suppose 3 will definitely occur? Before throwing the die, can you predict that the result will be 3 or result will be 4? No. That means it satisfies the second condition also. And third condition is the process we can repeat it infinite number of time. That means throwing of a die is also a random experiment. Similarly, I'm giving another example. Suppose we have a urn here. One urn is here. Urn means some kind of bag. And there are few balls. 5 balls are red in color and 6 balls are here which are blue in color. Okay, you put your hand into the urn and keep a ball, pick up a ball. So what will be the color of ball? It may be red or it may be blue. That means before doing the experiment, we can say that the result will be either a black ball or a red ball. But you can't say that whatever the ball you are picking, you are just picking up, it will be definitely blue ball or it will be definitely red ball. And third condition is we can repeat the process infinite number of time. So picking a ball from an urn is then also a random experiment. Okay, now next topic is what is the sample space or the event space. What is the sample space or event space? Sample space. Okay, the sample space is the collection of all outcome, is called a sample space. Is called a sample space. For example, if I toss a coin, in case of tossing a coin, tell me what will be the possible outcome. In case of tossing a coin, what will be the possible outcome? Yes, it will be either head or tail. So if I collect the outcome, then this collection is called the sample space or the event space corresponding to the random experiments tossing a coin. Similarly, if I throw a die, in case of throwing a die, what will be the possible outcomes? The possible outcome contain the number starting from 1, 2, 3, 4, 5 and 6. So in case of throwing a die, the sample space is 1, 2, 3, 4, 5 and 6. Okay, another example. Suppose we have 2 coins and we are tossing the coin simultaneously. So in that case, what will be the sample space? Tossing 2 coins. Tossing 2 coins. What will be the outcome? Look, the outcome will be first coin may show head and the second coin may show head, or first coin is head but second coin shows tail, or first coin it is tail and in second coin it is head, or the both coin shows tails. So in tossing 2 coins, the sample space are HH, HT, TH and TT. Okay? Okay. Suppose we are throwing 2 die. Instead of 1 die, we are throwing 2 die. Throw 2 die. So in that case, the sample space contain 36 point, like 1 in the first die and 1 in the second die, 1 in the first die and 2 in the second die, 1 in the first die and 3 in the second die, 1 comma 4, 1 comma 5 and 1 comma 6. Similarly, if in first die if it shows 2, then second die it may be 1 or 2 or 3 or 4 or 5 or maybe 6. So corresponding 1 in the first die, in second die possible may be 6 element, 1 2 3 4 5 and 6. Similarly, when first die shows 2, then second die may show any number from 1 to 6. Similarly, if the first die shows 6, in second die it may be 1 or it may be 2, it may be 3 or 4 or 5 or 6. Okay, so now tell me, what is the number of element in the event space or in the sample space in case of throwing 2 die? Can you tell me what is the number of sample space or even? Very good, this is 36. There are 36 element, 1 2 3 4 5 6, here 6. So total number of element in that case is 36. Okay, now tell me, have you understood what is the sample space and what is the random experiment? If you have any problem, you can tell me, otherwise I am going to rub it. Okay, no problem, very good. Okay, next topic is, what is the event? What is the event? Event. Okay, look, the definition of event is the collection of few element from the sample space is called event, or you may define it like that: the subset of any event, subset of a event space is called a event. Subset of a event, sample space is called a event. Okay, now let's see some examples. Okay, suppose we're throwing 2 coins simultaneously, tossing 2 coins. So in case of tossing 2 coins, the total sample space is h, ht, th and t, t. 4 point will be there. Now if I consider a event A, means at least one head. A is the event which implies at least one head in the die. So what will be the event in that case? At least one head appear. No, I am not telling about the probability. I just want to calculate the event. So look, this is the event space. So we have to choose all those events which contain at least one head. Now look, in the first point there are 2 heads. So at least one head is here. So H. Now in the second point, H, T. In that point, one head is here. So we'll write H, T and T, H. These 3 elements contain at least one head. So if I choose our event A, at least one head appear. So our event will be HH, HT and TT. Okay. Now suppose B is the event, which means no head appear, no head. no head appear. So what will be the event space, sorry, what will be the event? Only it will contain only one element which does not contain any head, that is t comma t. Okay, one element. Okay, let's see the event which means one head appear, one head appear. So what is the corresponding event? One head appear. So you have to collect all the number which contain one head. So you can see that there are two such element, one is h comma t and one is t comma h. So ht and th are the uh, event corresponding to this event space. Okay, let's choose one more problem, one more example. Suppose we are tossing two die, we are tossing one die, suppose we are tossing a die. So in that case the sample space will be 1 2 3 4 5 6. Now if I choose a event a, the number is less than 4, the number is less than 4. So what will be the what will be the event corresponding to this event space? The number is less than 4. So look, there are three elements whose value is less than 4, and they are 1 2 and 3. So the event space will be 1 comma 2 comma 3. Okay, let's take another event b. The number is greater equal to 2. The number is greater equal to 2. So in that case what will be the sample space? No, I am asking the sample space. No, I said greater equal to, not less equal to. Somrat and Chetana, not less equal to. 1 and 2 both are less equal to 2. I want the sample space which is greater or equal to 2. So we have to write all the element in the sample space whose value is more than or equal to 2. So the sample space will be 2 3 4 5 and 6. Got it? Okay, now next, suppose C is the event that the number is more than 6. The number is more than 6. Think before answer the question. Yes, because there is no element. No, there is no element. Not possible. Yes, very good. Ornella, no, it is not possible, because in case of throwing a die, maximum number we get is 3. We can't get a number whose value is more than 6. So it is not possible. Okay, so we can denote it by, we actually denote it by phi. Phi is a actually set having no element. Phi is a set having no element. Okay, or you can write not possible, because you don't know what is set actually, so you can skip this symbol phi. Okay, okay, very good. Now come to the next point. Event is done. Now what is the number of element in a set? What is the number of element in a set? Number of element in a set is also called the cardinality of the set. Suppose there is a set A which contain 1 2 3 4 and 5, this 5 element. Okay, so number of element in the set is denoted by n of A. N within the first bracket A is equal to the number of element in this set. Just count it, 1 2 3 4 5. So there are 5 elements, so n of A is equal to 5. Okay, suppose there is a set B which is equal to 2 7 9 11 and 20 and 25 and 27. Okay, so what is the number of element in the set n of b? Just count the number of element in the set b and write it here. 1 2 3 4 5 6 7. There are 7 elements, so n of b will be equal to 7. Okay, very good. Okay, now we'll define what is the probability. Definition of probability. Definition of probability. Okay, so let S is a sample space corresponding to any random experiment. S is a sample space containing n of S element, means number of element in the set is n of S, and A is an event containing n of A element, means number of element in the set A is n of A. Then from the classical definition of probability, it says that probability of A is denoted by n of A by n of S. Classical definition of probability says that the probability of A is equal to n of A by n of S. That means the number favorable for A by total number of element in S. Okay, this is the definition of probability. We'll use this formula to solve the questions. Okay, okay, now we'll consider a problem. Okay, and we'll try to find out the probability of the questions. Okay, suppose we are tossing two coin. Okay, so in that case we know that the sample space will be h comma h, ht, th and t comma t. 4 element will be there. We are considering a event which means one head will come. So what will be the event A? Can you reply me? What will be the event A? If A means one head will come, one head will come. Yes. So h comma t and t comma h. Two possible outcome is here, h comma t and t comma h. Okay, now what is the number of element in the set S? Total sample space, it is 4, and number of element in the set A, that is equal to 2. So according to classical definition of probability, it says that P of A is equal to n of A by n of S. Okay, now put the value of n of A and n of S here. So n of A is 2 and n of S is equal to 4. So that is 1 by 2. So here the required probability is 1 by 2. Okay, and note one thing, the value of the probability is always greater or equal to 0 but less equal to 1. The value of the probability will be always lie between 0 and 1. And why this case happened, we'll discuss in the next class. Okay, so students, if you have any queries, you can tell me. Otherwise, this class is finished here. Do you have any problem?